Hi, so you may have come across a new and upcoming field of science called quantum physics, which shows a lot of potential in futuristic developments currently being showcased in quantum computers and other hyper-functioning machines. However, quantum physics plays a more natural role to the universe and everything within it. First, we shall explore the quantum world by trying to understand briefly what the quantum world is. Quantum physics, which is also referred to as quantum mechanics and quantum theory, is a theoretical basis of modern physics that explains the nature and behavior of matter and energy on a subatomic level. The need for another branch of physics in this case is fundamental because the laws and equations that we know from classical mechanics do not manifest at an atomic level. You see, in classical mechanics, things are a lot more straightforward. Objects exist in a specific place at a specific time. In contrast, this is not true at a quantum level. Subatomic particles may exist in two different places at the same time. Furthermore, if we consider Newtonian mechanics with Maxwell's electromagnetic theory, which states that a charged particle in acceleration will emit radiation, meaning the kinetic energy will decrease, thus causing the atom to be unstable. This, however, is contrary to any observation. You could say that the journey of quantum physics began or was stimulated by the discovery of electrons from the cathode ray tube experiment by J.J. Thomson. However, tonight we shall start in the year 1900s with Max Planck. Planck had sought to discover the reason that radiation from a glowing body changed color from red to orange and to blue as temperature increased. He made the assumption that energy exists in individual units in the same way matter does and is quantifiable. Planck won a Nobel Prize in 1918 for his theory. As you can see here, the most charming, Albert Einstein won the Nobel Prize in 1921 for his work on the photoelectric effect, which supported Planck's idea that energy was quantized in quanta or photons. Electromagnetic radiation is emitted in bursts of energy as photons. In 1923, de Broglie proposed that as waves can exhibit particle-like behavior, particles should exhibit wave-like behavior as well. He proposed that the same relationship between wavelength and momentum should apply to massive particles as well as photons. Principles of quantum physics are being applied in an increasing number of areas, including quantum optics, quantum chemistry, quantum biology, and quantum computing. Here on the bottom right, you have a quantum microscope. In Japan's Hokkaido University, researchers developed the world's first entanglement-enhanced microscope. This fires two beams of photons at a substance and measures the interference pattern created by the reflected beams. And above it, you have a quantum computer. A quantum computer is a super powerful computer which works with particles that can be in superposition rather than representing bits. Such particles represent qubits, which can be 0 or 1 or both simultaneously.